We hear the call for interoperability. We see clinical systems overwhelmed by raw, poorly structured data, and we feel growing pressure to extract meaningful analytics without adding burden. When FHIR data moves between systems, many of the hardest problems aren't clinical, they're structural. Associative arrays give us a way to reason about those structural problems at scale. There is a data structure that is deceptively simple and surprisingly powerful: the associative array. It is taught in the university, used in large-scale data systems, and formalized in published text. What caught my attention was not novelty, but how naturally associative arrays align with the problems of interoperability. This is a serious idea with institutional backing, and it explains a lot. Associative arrays are widely used, but inconsistently defined. In this discussion, we use the published definition, one that is rigorous, mathematically grounded, and unambiguous. The rigor turns out to matter. In healthcare settings, these distinctions stop being academic. We have here the short version. The formal definition next to it is longer and mathematical. It is included because precision matters. Associative arrays can help us with interoperability, crude low-level data, and analytics. Interoperability comes first. Interoperability is hard because the data structure works against you. This is how an associative array works conceptually. Rows and columns are ordered. There is a second characteristic to notice here. Watch what happens to the values. Instead of remaining in the cells, the values are appended to the column key, separated by a delimiter. The cell itself is reduced to a simple logical indicator. 1. No information has been lost. We've changed where the information lives. Taken together, ordered rows and columns and values promoted into the structure, these characteristics are what makes algebraic operations possible. We will return to this transformation later. How would a FHIR resource be represented as an associative array? Start with what the specification already gives us. Every FHIR resource persisted on the server is assigned an ID. Within the scope of that server, the ID is unique and typically stable across versions, but it carries no business meaning. That makes it an ideal row key. FHIR already gives us something equally useful on the other axis. FHIR path provides a precise, canonical way to address every element within a resource. That makes FHIR path an ideal column key. Put together, a resource ID, a FHIR path, and the value of that path form a simple row-column value triple. Together, the resource ID and FHIR path give us a stable, specification-driven coordinate system for the data. What you are looking at is a single FHIR resource represented as an associative array. The row corresponds to one resource. Each column corresponds to a FHIR path. While we are only showing a small subset here, fire resources are inherently sparse across all possible paths, and associative arrays handle that naturally. For readability, the column labels here are abbreviated. The legend maps each abbreviation. For now, the values remain in the cells. That is intentional, but this choice has consequences and opportunities. In the next videos, we will use associative arrays to address some of the most persistent problems people encounter when working with fire in the real world. We will touch on profiles and implementation guides. They often look compatible until you try to use them together. Extensions accumulate, local, proprietary, and unavoidable. Terminology systems don't always line up, even when the codes look similar. Workflow assumptions differ, and clinical context gets lost. Versions fragment, R4, R4B, R5, and compatibility becomes conditional. Serialization differences introduce friction where none was expected. Validation rules vary between servers with inconsistent results. And transport level constraints, security, authorization, SMART. These things shape what is possible before data even moves. What you've seen here is a change in perspective. By stepping away from how fire is serialized and focusing instead on how the data is represented, we gain room to reason about structure, scale, and meaning. Associative arrays give us that room. In the next videos, we'll use this representation to take on real-world fire problems one at a time.